second day of Smart City Sweden's event about building in wood and to this Swedish pavilion at Expo 2020 in Dubai. My name is Annika Nilsson and I work for the Swedish Energy Agency, and we are one of 8 state authorities that's standing behind the Smart City Sweden platform. Yesterday we had really an intense and inspiring day together, and here from Dubai we, for example, learned about one of the boldest buildings so far in wood and the struggle to get the Swedish pavilion in place in time for the Expo. Before we hand over to Stockholm, I would like to turn to my colleague at Smart City Sweden, Gina Aspelin, for a brief introduction about Smart City Sweden.
Thank you all. So my name is Gina, and welcome to all of you in the room and everyone who's here digitally. So as you know, Sweden is committed to the Sustainable Development Goals, especially the climate-related ones. And this is where Smart City Sweden plays a role. What we do is that we gather the very best solutions for city challenges that we have in Sweden, and we demonstrate them for an international audience. We do this by arranging physical and digital visits. And we also want to create dialogues between international groups and our network on how we can bring these Swedish solutions to an international environment. As Annika pointed out, the Smart City Sweden network includes several authorities, but also hundreds of companies, regions, municipalities, and also research institutes. And our aim is to facilitate discussions, not only how we can bring solutions abroad, but also covering subjects as policymaking, regulations, education, and also business models. But let's talk more about that later and continue with these very interesting subjects.
Yes, the theme for the Expo is connecting minds, creating the future. So let's do that together today. And once again, a very warm welcome, everybody. And now over to Susanne in Stockholm.
Thank you, Annika and Gina. And a warm welcome to you all to the second day in this week of events called Bold Buildings, hosted by Smart City Sweden. And the first session today is Smart and Safe Buildings. My name is Susanne Rudenstam. I'm Managing Director for Swedish Wood Building Council, representing the wood building industry in Sweden. Yesterday, we talked about climate, life cycle assessment, and the need for construction industry to accelerate the change into decreasing climate impact, and a circular way to meet the demands from growing cities. We talked about how wood and wood construction could be an enabler for this green transition and to help reach the Sustainable Development Goals that is now being discussed among the world's leaders in the UN conference COP26 in Glasgow. The purpose of this first discussion is to talk about how to secure that the buildings we are building are safe, both during construction phase and to use, and how we are using the technology to fulfill that. With me here in the studio, I have Fredrik Hiort, fire safety engineer and a senior partner at Briab, Thomas Bengtsson, CEO and founder of Woodsafe, and Johan Granström, market segment lead Smart Cities at ABB. Most welcome to you all.
Thank you.
Thank you. Thank you.
First, I feel that I guess I have to ask you the obvious question that I guess many of you in the audience in Dubai that are seated in the wooden pavilion are asking yourselves. How is it possible to build a fireproof house in timber, a combustible material? And I start with you, Fredrik. You and your fellow colleagues were responsible for the fire safety design at the forest in Dubai.
Yeah. Well, I see it a little bit like being a TV chef. The way we managed to do it was by taking different parts into it. The right ingredients being innovative solutions and materials. The right chef, the engineering knowledge of building in wood from Sweden. The right equipment, using digitalisation, Internet of Things, and so forth. And finally, we top it off with a lot of dialogue. So that's pretty much how we manage to provide an understanding for our solution.
Interesting. I guess we will get back to your list of ingredients a little bit later on. But also a question to you is, and we know that Dubai is a city in a country where some of the hardest regulation in terms of fire in the world. So how was it possible to get the project through? How was the process?
Yeah, I would say that we prepare ourselves with the three first ingredients that I was talking about, and the final way to create an understanding for what we did was the liaison fire safety engineer that we have had down in Dubai, and also the continuous dialogue with the authorities to show them that this is a solution that might not be accepted or understood or used in Dubai, but it's a way that we know works. Hence trying to get them to understand that this is a good solution, equivalent to building in any other material.
Knowledge and competence and continuous dialogue.
Yeah.
And you, Thomas, your company was responsible for a lot of the material that is now used in the pavilion.
Yeah, that's correct.
How are you? What are your thoughts on the demands of the products?
It was a really fantastic project. At the first, when we got the call for the pavilion, we didn't know about it actually, but our work for the fire safety was to impregnate all the logs and all the cladding. So that was our job. Yeah.
So yeah, we will get a bit of a presentation from you later on, and the description on how you actually do that.
Yeah.
And Johan, perhaps a question to you is, Fredrik is mentioning IoT, Internet of Things, as a part of the solutions, and what is your immediate reaction or response to that?
Well, indeed, IoT and smart technologies is really important, and I see from a building and smart city perspective, it's really about getting the technology to add value in a planning phase, through the construction phase, and finally through the complete life cycle phase, so that we can ensure that it's sustainable through its complete life cycle, really. So that's really interesting, I would say.
Are we just in the starting point, or is it widely or becoming more and more widely used?
I would say we're pretty much in the starting point, because until now, I don't think anyone built a stupid house today. Most of them will build a smart house, but it's mostly smart from its own perspective. It doesn't really interact with the world around it, and I think that is about to change, and that is kind of essential to move to a life cycle perspective.
Interesting. We will dig a little bit deeper in that too. So back to you, Fredrik, and actually to the headline of today's discussion. What is a safe building? Could you explain a little bit deeper on your subject?
I would say a safe building is a building that is safe to be in over the entire lifetime of the building, not only in terms of fire safety, but in terms of all different aspects of safety into that. But I'm going to try to dig in a little bit into the fire safety issue, because I believe that is something that a lot of you wonders why and how could we do it. So I'd like to talk a little bit about the ingredients that we've talked about and the 4 parts of making a building fire safety in terms of the fire safety. First of all, we've worked with choosing the products and solutions, and actually using products and solutions that isn't new. Talking about innovative solutions isn't not only talking about new things, but new ways of using materials and solutions that we actually have good knowledge about. And in Sweden, we have good knowledge about historically of building houses in wood. So in terms of the wood, we've chosen fire retardant impregnated logs, as Thomas has been talking about. We have been using fire safety alarm, sprinkler, and different sorts of solution that actually is knowledgeable solutions, but we've sort of made them together so that they give a safe solution. In terms of innovative knowledge and in terms of engineering knowledge, it's the same thing. It actually boils down to knowing how to use the materials and what to do to be able to say that the building will stand for the time it's supposed to stand, that people can evacuate and its safety. So it's a question of having the knowledge from an engineering perspective. For the wood, we've had the opportunity also to use innovative technologies, Internet of Things, using that, and we also worked with digitalisation and quality assurance in the process, which is actually something you should have, whatever building you are building. But we've been able to use it to ensure that we have a good building. It can be, for instance, using a 3D BIM model when we've designed the fire safety, making the information moving along during the entire process. It can also be the standard quality assurance process that Thomas and his colleagues is having in their production process. So it's a lot of work in terms of making the process better and safer. So with those 3 components, we've also realized, which we know also from different kinds of projects, that dialogue to make everyone understand the pros of using that methods and take away the frightness of using something that is new to you. So the dialogue has really been a key question in making this success. So that's a little bit more on the 4 ingredients in working like this. And I would also like to go back a little bit to the digitalisation part. And the reason that is interesting is that we've had a few incidents and large catastrophes like the Granström fire with devastating consequences of that kind of fire. Hence, the UK government are now legislating on the golden thread of information, really making the information live not only through the design phase, but into the entire building lifespan, life cycle, including the possibility to make it possible to work with the circular reusing of materials and things like that. So in the case of the wood, we've also worked in those terms to trying to safeguard the fire safety, not only during the first year of usage, but in a longer perspective, using digital tools to actually make the information move from user to user
throughout the lifespan of the building. You are putting a lot of emphasis on dialogue. Do you have a common language among your fire safety engineers in the world? I mean, a fire is a fire, whether it's in Dubai or in Stockholm or elsewhere.
Yeah, I would say that there are differences in legislation from country to country. But as you say, a fire is a fire, and the fire safety engineering profession is fairly one language, so to say. The challenge usually is the experience that you have. You have experience from your own region, from your own legislation, meaning that you start to think, is that really possible? Because you haven't done it before. So the language of fire safety engineering is universal, but the experience, the backpack that you're carrying of experience, make you look at it from different perspectives. So that's why you have to have the dialogue. And well, we don't see it this way. You see it that way. Why is it in a specific way?
Well, I guess, I mean, we're getting back to the COP26. We're in a stage now when we will have to do a lot of things that we haven't done before. So dialogue is a key here. Thomas, your company, you delivered a lot of the material. Do you see that there is any specific requirements from other markets? I mean, you are operate mostly in Sweden, but also on other markets. Is there any special requirements in Dubai in this case?
No, not especially in Dubai, but the wood building is going all over Europe and all over the world actually. But for the pavilion, it was very important to keep the feeling of the logs, so you don't hide it behind some coating or something like that. So the feeling was very important, and also. It's very tricky part to tell them that we can use timber in Dubai, because, as Fredrik say, it was not allowed. But our process is that we have a cylinder, and we, under pressure, we impregnate the logs. So you have 4 sides of fire safety on the logs and all the cladding and everything. So that was a key. You shouldn't see it, but it should be impregnated and safe.
I guess you have also some details that you can share with us.
We have some picture here. You see now on the picture here, you see the logs coming in from the north of Sweden. And you should also see pictures when they go into the cylinder. It should come up a new picture here.
A lot of logs.
Yeah, it was about, I think it was about 250, 300 cubic meters. And it was a really tricky part to solve the storage actually, because when we get it to our site in Västerås, it was cold winter, snow outside, so we have to take in all the logs inside. So that's it. And you also see the impregnation here on the picture. You see it's going in. It was about 300 cubic meters, but we could only impregnate about 4 or 5 logs at a time. So it was a really stressful time at that point.
How long is the process of doing?
About 60 minutes or something like that, depending on what. It actually takes longer time to load this cylinder now with the logs compared to have the treatment. It was really tricky part, and also the safety for the staff, because it's it's rolling around with the forklifts.
What is actually the stuff that you impregnate the logs with?
Do you really want to know?
I guess a lot of us want to know.
Actually, when the impregnation is liquid, you push in around, let's say, 200 liters of the solutions. But when you dry it, the substance that are still in the material is like a crystal water. So when it's burned, when it's when a fire starts, it's melting and it starts to create a little bit of water, but actually it's the pyrolysis gases. It takes that out. So it's just if you're gonna burn wet wood, actually. So it will not burn itself.
So it triggers a kind of self-extinguish.
Yeah, if you have something, if you have a flame on it, it will char all the time. But as soon as you take that away, it's going down. So it's like crystal water inside the cells in the timber. That's it.
Thank you. I guess we have seen some pictures rolling here.
And it was also a very tricky part to sew. The logs was 30 meters long. And the doors is just 6 meters. So we need to get special equipment to handle all these logs. Yeah.
A special order for a special building, indeed.
This was unique in all the way.
Perhaps not. Well, hopefully we'll see some of those in the smart city onwards, but perhaps not that many.
No.
So the smart city, you were touching upon that, Johan. What is a smart city?
That's the big $10,000 question, I guess. Well, from my point of view, when I talk about smart cities, I primarily address the energy challenge, because that is really something that affects us all. And it's like we said in the introduction, it's much about the footprint really of a building over its lifetime. Will come a lot about the energy. So before I come into a specific example, I like to address this from a more generic approach, because what I see is that we have kind of 4 different innovation tracks related to smart cities. We have the technology advancements, the innovation related to that, of course. But we also have kind of a regulatory models we need to reconsider how to do that. Thirdly, we have the commercial business models that need change to kind of stimulate the change we need. And finally, it's about behavior changes, really. So that is the mix we have to address when we talk about smart cities. And the other thing about that is how the energy landscape is transforming, because we are going from a history where we have plannable power in power plants, right? And are moving into more of a distributed system where we have solar panels on the roofs, we have energy storages, we have electric cars that need to be charged and so on. So we need a different approach how we distribute, consume and produce energy, really, into more of an ecosystem, I would say. And to address that in the building space, it's really about transforming the conventional way of connecting buildings, being passive consumers of energy, right, to becoming assets to the city. So that is a really, really essential part of it, as I see it. And like I said in the introduction, you can always discuss what is smart with a building. And it starts, of course, with a layer of smart features for the buildings and the ones using the buildings, right? But what we would like to address is really to add, you could say, 2 layers of smartness too. So you have the first one is about intelligence and the features, right? The next one is really about emotional intelligence. How can we make the building to take active choices that are better for the energy system, better for the world, right? Less CO2 footprint. And the third layer is really about the learning capabilities or learning intelligence, one could say. And that is really about what happens when we introduce artificial intelligence, for instance, to learn more about the building. How can the thermal model of a wooden construction serve as an energy storage, for instance? So I think we have a slide up now from one of these examples, which is actually Sara Culture Center in Skellefteå, which is one of these projects where we have, in close collaboration with Skellefteå Kraft, which is the local energy company, we have developed this solution. So what we really have done here is to put inside a building, we have state-of-the-art equipment when it comes to the electric distribution, right? We have 4 solar installation on the roof. We have a battery-based energy storage. We have a heat pump. We have district heating, and of course a connection to the electrical grid, right? So this is kind of units that we can get data from, and we can also control them. So what we have done is we have added kind of a brain called Optimax, which is an energy management platform. And it includes algorithms to make these choices that I addressed earlier. How could we minimize the CO2 footprint for this building, for instance? And then we have the top layer, which is really about adding ears to this building, one could say. So it's really about understanding the surroundings, the rest of the city, and actually connect it with the production units of Skellefteå Kraft. So all together, we have added, like I said, the intelligence, the emotional intelligence, as well as the learning capabilities. The building can actually learn, understand, and make active decisions if I should use the heat pump or the district heating at this very point to reduce the CO2 footprint for the building, based on the city's need of energy in general.
So the building is actually optimizing itself.
Indeed,
at all times.
Yeah, and this is really important since this is a culture center. It will have a very dynamic load pattern, one could say. If it's a concert or if the hotel is fully booked, it will have a very different load profile. And this is capabilities that the house need to have to learn better how I should utilize the resources I already have. For instance, can I use the wooden structure to store energy to manage a peak load later on? But in the same time, it needs to make choices that's maybe not best for me as a building, but best for the city, best for the world to reduce the CO2 footprint. So this is really about managing the CO2 footprint over a lifetime.
That's very, very interesting. And Sara is a new building, just inaugurated. We talked about it a little bit yesterday and got a presentation, inaugurated 1 month ago. But how does these new buildings that we are building, how are they interactive with the cities and the old buildings and the old people, perhaps, but people also living in the cities?
Yeah, that is a good question, of course, and that's a reality we have to kind of manage. So we have examples, for example, from Norway in Trondheim, where we did a project where we have kind of this hybrid environment. So we have one building which is kind of similar to Sara Culture House. So it's new, it has the latest technology and so on, but it also has 4 or 5 existing buildings as well. So what we have done there is really to connect those buildings, for instance, just to get the load in real time, the energy usage. And that is actually being used by this more integrated building to have a better understanding how the surrounding buildings, how their energy demand will look like in an hour, in 4 hours, or tomorrow, to make active choices with the assets I do have at my building. And all together, we can make kind of this sustainability progress, accelerate that based on that we have better insights what's happening around us.
Indeed, very interesting. And you said that as perhaps the fourth ingredients from your side was also the behavior of people. Indeed. And I mean, we build the building not for themselves, but for the people that lives in the city to use them.
Yeah, that's a very good point. And I think smart city as a terminology is often about the technology, but as you said, it's all about the people and the people living in there, right? And I think we have another example of a project we did in Västerås, where we actually connected this CO2 footprint to actually connect that with the people living in the building. So we had kind of this nudging feature that connected that the CO2 footprint had a visualization. So if it was a red light at your desk, it was not a good time to charge your mobile phone, for instance. Because if we can make people to do these kind of choices, talking about behavioral changes, to move our energy patterns, how we use energy, we can actually make a big difference regarding to the CO2 footprint.
I think, or I believe that also the behavior of people is also something that you have to take into account when designing for fire safety.
Yeah.
It's always people living in those buildings that are responsible for.
We talked about dialogues a little while ago, and that comes to people behavior, and of course evacuation and how you behave in a fire or in an evacuation situation is as much important as how you actually just built the building, using the knowledge of how we behave to make a building as optimized and good as possible in terms of fire safety too. So yeah, definitely. Could I ask a question, because your examples that you were talking about was Trondheim and Skellefteå in the northern part of Sweden. Do you see any difference in the way of northern Sweden, where you're heating buildings more than in, for instance, Dubai, where I would guess that the challenge is more of cooling the buildings?
Yeah. Obviously, there's different targets here to address, but in the same time, it's energy flows in one way or the other. So if we use a lot of heat in northern Sweden, we in other parts of the world, that's a cooling issue, right? But I think it's really the same kind of challenge we need to address here and we need to solve. And it's really about how can we solve that basic demand of having a good temperature indoors, using the less energy and the less reducing the CO2 footprint as much as possible. So I believe that cooling is really the same challenge here. So we need to make sure that we control that based on the access to energy, to green energy mainly, that we do have. So I think and believe it's the same. We can store cool as well as heat.
And I guess the behavioral nudging part is universal wherever you come.
It is because I believe that it's the same thing as when the transport sector is electrifying right now, and when everybody get home to work and you plug your charger in, right? What will happen then? So that is also about adding a layer of intelligence to move those kind of peak demands in time and space to more flatten that curve, and that will enable us also to reduce the CO2 footprint. So I think it's the same challenge here, it's just a different kind of application.
Well, we're experiencing, or we are in the midst of energy crisis right now, and I mean we are quite aware, each and every one of us, also here in Sweden, that the price for our energy consumption has gone rocket high, and we are even facing perhaps a crisis on the actual getting any energy at all. What do you think will be the strongest driver? Would that be the cost of energy, or is it the footprint that the energy consumption causes?
I think they are strongly connected, first of all, and I think that it will not be energy that is the most pricey; it will be power. So that's very important. So buildings need to have the capabilities of what you call shaving the peaks, right? So we need to lower the power output from the building, because that's going to be really, really expensive. And in parallel, I believe that we will have a much more tougher regulatory and pricing models for CO2 in general, which will, of course, also affect how you utilize energy and when. So that's really important, because I think the energy system is turning more into a much more dynamic kind of marketplace, where you will need to have the ability to orchestrate all the energy assets to be optimized towards pricing and CO2 footprint in the end.
How are we going to do that? How will we make this happen? I mean, some of us, you and your fellow colleagues, perhaps Johan, has the knowledge and the understanding, But how could you make this happen throughout all the layers of people that needs to both shape the policies and regulation around the transition, but also the one that's actually going to do it?
Well, I believe this is a truly case for collaboration deeply. It's within the what you can say the building or construction phase. All the architects and the ones looking into the design and construction. It's about the regulatory models, like I said before, and it's also about designing from the first place to be energy efficient. Because until now, this has been kind of a waterfall process, one could say. We have a building here, now we need a connection to the grid, right?
Yeah.
But if we can start from the other way, we can actually optimize the static design as well. Building this kind of solutions from the beginning will enable us to have maybe a smaller transformer, a smaller power output, and all that. So I think it's about closing the gaps, really. But we are depending on that the regulatory models for energy and electricity and so on also is on this journey, because we have to limit that gap. Because now I think the technology advancements is a long way, much more in the future than the regulatory models is. So once again, it's about collaboration.
I guess you can say that we have more or less the same situation when it comes to fire safety design. We have deep knowledge. We know actually how to design, and we could build safe buildings already today. But how do we pass on the knowledge, and how do we make sure that this knowledge that we have and the knowledge about both products and systems are being used in Sweden and in the world? It's a big question.
I would say that's a great final question on how do we do it, and I believe that we're using the digitalization, we're moving in that direction. But the world is full of gaps, and in terms of fire safety, the major gap is between construction and the as-built start to use. The information going from the one who wants to build the building, the ones that are building the building, and the ones that are going to use. And historically, we've seen them as three separate entities, and we have to see it as one single chain of information. Just as in terms of building smart, that's the only way to make fire safety better, energy usage better, and people understanding how they are going to use the building in the best way. And when I'm listening here, I'm starting to think about how do we nudge in the fire safety area? How do we nudge people to do the right thing, making them want to do the right thing? So that's something that I'm going to take from this discussion on how do we nudge ourselves to close the gaps.
I mean, you have the regulatory perspective, of course, but also you can say that there is a power with them who actually get the house built. I mean, municipalities and developers that is procuring safe buildings. They could, when they have the knowledge, they can also be much tougher.
Yes,
onwards.
I agree.
And I would like to add to that as well, that it's really about having this holistic view on how we build the city of tomorrow, because we are facing, if we not do that, we are facing kind of a hyper-fragmentation, I would say, in a technology point of view. And that's a tough road to head for. And I think also the municipalities also need to move closer to the actors, right? Because all the how you can build the buildings and so on is defined by the municipalities, right? So we need a lot of better collaboration there, as well as demands, really. We need to have much tougher demands on how we can introduce new buildings into a city. So I think that's the importance as well.
Yeah.
We are going to talk a little bit about cities of tomorrow and then also using the existing buildings. But before that, I just have a question for you, Fredrik, and perhaps Thomas also. It seems to me that the competence and the knowledge among Swedish fire safety designers is really big, because you meet these Swedish fire safety designers all over the world. They are working in Australia, in Canada, in South America and elsewhere. Are we especially good?
I'm kind of smiling proudly because Sweden has always been in the forefront regarding fire safety, and in terms of most of all the university in Lund, which is internationally renowned for being in the forefront of fire safety engineering and research on fire safety. Since I studied there myself, I'm smiling with pride to that question. So yes, there are a lot of fire safety engineers around the world working.
Considered to have a great knowledge.
Yes.
Interesting.
Yeah.
I think that we should have also just talk a little bit on the fact that the future cities are not just the new builds. It's to a very high extent also about how we use the existing buildings and make sure that they have a continuous and prolonged lifespan. So how could these new, so to say, technology also be applied in the existing network of buildings? Starting with you, Johan.
Well,
I mean, business models was one of the things that you mentioned.
Yep.
Business model for circularity was something that we also talked about yesterday.
Yeah, and I think that's really important, and I think we need to find market mechanisms that kind of build the incentive programs to be a part of this new marketplace being born, really. So I think that is one thing we need to consider. How can we, with price signals and market mechanism, finds kind of get a movement in that direction we want to. And once again, I want to connect that to the holistic view of the energy system, because it could be a really good idea to, from a pricing level, to, for instance, decommission district heating from a building and set a heat pump instead. But from an energy system perspective, that's not the best thing to do, right? So we need to find the business models and the market mechanisms to find the incentives, really. That's what it's all about. It should make sense for an owner of an existing building to be an active part of an emerging energy market. So I think it's a lot about market mechanisms.
That is also connected to what you pointed at before, Fredrik, on how we secure the quality throughout the full lifespan of the building, but also including renovation and refurbishment and etc.
Yeah.
How is that being secured from your point of view?
Well, first of all, existing buildings, the ones that are standing in 2040, is pretty much all of them built already now. So even though we are building new houses, the existing houses, buildings are frankly more interesting than the new ones. To put it so I believe that the as with the energy system, the authorities have to incentivize us to really take care of the fire safety for the entire buildings, because when the regulator says that something has to be done, then one part of the innovation process starts, where you try to find solutions to actually meet those. There's another part of the invention too, the one that is happening on other incentives, not from the regulator's standpoint. But I think innovation driven by regulatory incentives is a way to create innovation to sustain the building fire safety and overall safety over the lifetime of the building.
What is your opinion there?
Yeah, I agree. It's also very important to understand that I read on the news today in Netherlands, for example, they're going to build, was it 20% all new buildings in just a few years? In France, it's 50%. So it's very important that the choice of fire safety that is correct, and the entrepreneurs follow what, for example, Fredrik's written on the paper. So fire safety, we can build much more with wood if the fire safety is good, and of course it's sustainability and everything like that.
If the fire safety is good and we do exactly what is designed.
Yeah, but it's very important because we have the expertise and we need to follow the expertise to continue build with wood, because if we have a gap between what, for example, Fredrik say right down to use, and it will not be used like that. We have this Greenfield Tower example, for example.
Yes, I mean, the issues regarding fire safety has really been increasing, or the discussion around fire safety engineering has really been increasing since, the tragic incident.
Yeah, you have Italy also, for example. So it's a lot of talk now about fire safety.
We have a tendency to be reactive to things that has happened instead of being proactive so major catastrophes have a tendency to push us forward in what we have to do.
That's a very good bridge to the part where we are about to wrap this up. We're going to go to Dubai to see whether we have any questions from the audience there. But in order to be proactive, do you have any short top advice to our listeners on where to start?
Being proactive. I'm going to come back to this collaborative approach, because I think that makes sense, talking about being proactive. Being proactive is knowing more. So you need to speak with more experts, more people with new perspectives to kind of move from the way we have always done things, because we can't keep going doing the same thing and expect a different result, right? So I think get more people and new kind of competencies around the table.
Here.
Yeah,
Definitely.
I'm agreed.
Oh, we all agreed. Thank you so much for taking part in this discussion. And then we go to Dubai. Hello, Annika. Do we have any questions to our panelists from the audience in Dubai?
Yes, I think we have. But I would just first like to address our audience here in the pavilion in Dubai, that it's you're more than welcome to put forward any question. Just raise a hand and you will get a microphone. So, but we have one through our chat, and I will read it to you. With more sensors and connections, do you have any advice on how to avoid that the technology gets outdated too early?
I think that one.
I could take that one. Yeah.
Take it.
Yeah. Well, that's a really important question, because it connects also to that we have an already existing kind of installed base of buildings. So I think we need to find ways of having solutions that is scalable, first of all, and then since I'm coming from an industrial background, I would say also that standards are really, really important, because it's so easy to get caught that you do kind of a local solution that doesn't have this kind of life cycle perspective, and it can't communicate with anything else but itself. And then you kind of misses the target. So I would say standards is really important part of this.
Developing standards.
Yeah.
Yes. Great. Thank you.
So before I get into another question regarding fire safety, I was just wondering, because it was very interesting to hear you tell us about how you treated the logs in this building we're right now, and we are hanging in a tree hut above the logs here in Dubai right now. So I didn't get it when you talk about fire safety in this, this meeting room, for example. Is it a question of treating the material, or is it a question of have another system for fire safety, like more exits or?
I would say, sorry, Thomas.
Yeah.
I would say that it's a combination of all. It's both the materials you're using to provide the right internal material lining. It's a question of how you plan the bearing of the house. Load bearings of the house. It's a question on how you plan exit routes and things like that. So it's a combination of all of the above.
It's a complex.
Okay,
Yeah.
So, I see. So this is the last question I have right now, and that is, what kind of tree is the safest sort of wood?
That's perhaps a question for you.
Yeah, it's
Thomas.
depending on how you're going to use it. The higher density, the better protection the wood had itself. But actually, most wood can reach the highest level. For example, for the Euro class, it doesn't matter if it's pine or spruce or cedar, whatever. But the higher density you have, the better. So, for example, if you have a red western cedar, is very low density, and if you go up, for example, on oak or some core of pine, that's better because of the density.
So again, it's a question about competence and knowledge on how to you treat each and every species. Yes. So it varies, but the solution varies as well.
Okay, thank you. I don't see any raised hands here in Dubai, so I guess we're done here for now. Thank you.
Thank you, Annika. And then I actually have some questions in the chat here. We don't have time for all of them, but digitalisation demands energy to function. How does the lower energy of the building? How does that lower the energy of the building? When you put a lot of technology in the house.
Yeah, I understand the question. Yeah, of course, technology is kind of it build the cost, obviously, as well, to add more technology. But over our life cycle, it's as we see it, we can calculate pretty much the return of investment, because I think that's a part of it as well. But of course, we also have to kind of forecast how will the energy market look like tomorrow, because it's one thing today when we have in Sweden anyway, we have pretty low energy prices, and as I mentioned before, I think the power prices will go up, but the energy prices this year have been quite tough as well, especially in this part of Sweden. So I think it's hard to predict, but of course it makes perfect sense to add technology to be able to optimize, because I think it's a lot about future-proofing, because a building going to stand there for 50, 100 years, who knows? And we're going to be building the infrastructure needed for that.
Thank you. We have a question regarding the timber material that I think you, Thomas, could answer. How can you build with timber in countries with termites and the climate that perhaps destroys wood?
Yeah, it's a good question, actually. The termites, when we impregnate, for example, we don't have any poison in the flame retardant, but the taste of impregnated wood, the termites don't like that, so they don't attack the logs, actually. But of course, it's a problem for these small bugs. And about the sun breaking down wood, but that's the same thing all over the world. So, but once again, the termites, we had that discussion when we have these projects up and running. And we show them some paper from the States, because our liquid comes from the States from the beginning. So
I would like to add a little bit because our house in Dubai has a lot of exposed wood, and building in wooden material, in sustainable wooden material, isn't only being able to show it. It's popular to show it now because it's a statement. We are building a sustainable building. At the same time, you can use wooden buildings and wooden materials for the bearing constructions inside the building. So even though the building that you're sitting in right now is made of very much exposed wooden material, the typical wooden building would be a building where it's not that much exposed wood, and that is protected and covered by interior linings and things like that. So bear in mind that you can have wood inside of the structures too. That is not exposed for sun or wind or rain or termites or things like that.
Yes, that's a very good point. That's typically the structure is not the same as having a wooden facade or showing wood. Thank you. And there is actually also a question that are there any precautions in building with wood taken for natural disasters such as earthquakes? I don't know if we have any of our expert panel here that wants to comment on that one, but otherwise I could say that that's of course a very important question as well, as we know that we are building a lot of buildings in places on the earth where earthquakes happens, and same goes for those situations. You need knowledge and you need competence, and then there are solutions to solve that. So there are being wooden houses built also in areas where there are earthquakes. So I think that was it. I don't think that we have any more questions, nor in the chat or in the conference room in Dubai. So by that, I think we end up here. And I thank the panel, Fredrik, Thomas, and Johan. Thank you very much for participating here today.
Thanks for having us.
thank you.
Thank you so much.
Thank you.
And bye for now.